Okay, so this problem here is problem 11 from 2016 AMC 10A. It says, find the area of the shaded region. So it says, find the area of the shaded region, and we have a graph. We have some side lines, and I'm just going to assume that these are all right angles because, firstly, we already know that this is a parallelogram, and secondly, the graph just looks like a rectangle. Like, it's common sense that it's a rectangle. It just looks like one. Without the rectangle part, we can't exactly work further on with this problem. So, how do we figure out the area of two weird-shaped quadrilaterals? I mean, okay, two sides are equal, but what about the other sides? You can't do anything about this. So how about we just draw a few lines and divide this into smaller triangles? So we can obviously divide this into smaller triangles and then figure out the area of the smaller triangles, which is probably way easier to do than figuring out the area of the weird large quadrilaterals here that we've got. So we draw this line and we have four smaller triangles. Right now we're going to try to figure out the area of these two triangles first. So we draw the height and we draw the altitudes. I'm just going to use a dashed line. So this is the altitude here. And for the tall triangle, this is the altitude here. So notice that the two altitudes actually form one straight line, and because they have the same vertex, and their bases are parallel because we're in a parallelogram or a rectangle, if you can assume it. So we have the altitude is on the same line, and we want to figure out the altitudes. So we have H1 and H2. So the areas of our triangles is going to be H1 times 1 over 2 plus H2 times 1 over 2. So base times height over 2. So this is just 1/2. If we get the factor of 1/2 out, we have 1/2 H1 plus H2. However, luckily we know H1 plus H2. What is it? So this whole line here is going to be the altitude, right? So this line here is just going to be 5, which is the width of the rectangle. So we know that H1 plus H2 is 5 because the altitudes here sum up to this whole width. So we have 5 over 2 is the area of our two triangles. So we want the area of our bottom triangles now. So these two. Okay, so they still have a base of 1, and if you can guess, you're probably going to draw the altitudes of these again. So this is the altitude on one side. And we know that this is also going to be the altitude on the other side. So basically we have two altitudes again, and we can call them H3 and H4. The sum of the area of these two triangles is going to be H3 over 2 plus H4 over 2, basically 1/2 base times height, which is just 1/2 H3 plus H4. So what's H3 plus H4? We know that H3 and H4 are on the same line because the bases are parallel due to the parallelogram and also rectangle property, and we know that the vertex is the same point. So we know that H3 and H4 are on the same line. So we know this line actually just sums up to the length of the rectangle, which is just 1 plus 7, which is 8. And I mean, it just looks like it, right? So 1/2 times 8 is just going to be 4. So where's our answer? The answer is just the sum of these two areas, because the sum of this one is the area of two of the four triangles. This is 2 of the 4 triangles. So this is the other two of the four triangles. So we have 5 over 2 plus 4, which is equal to 6 and 1/2. So that's our answer, and our answer is D. So the key in this problem is we have to visually accept that this is a rectangle, and we have to understand how we can split this into two separate triangles, which we can draw the height of. Now when figuring out the height, we realize that h1 plus h2 is the width of the graph of the rectangle, and h3 plus h4 is the length of the graph. So thanks for watching. Bye!